Okay, so something else you should be familiar with from year 10 is the principle of moments. You should be able to write this down in an exam, so it is something you have to learn off. So the principle of moments states that when a body is in equilibrium, that first bit will get you a mark. By that we mean it's not moving, okay? It's not rotating, it's not spinning. So this only applies in a very special case where a lever is balanced, we might have said in year 10. In that special case, the anti-clockwise and clockwise moments are equal. And the very last thing we have to include is only if we measure them about the same point, which is usually the pivot, so about the pivot. So when a lever is balanced, or when an object is balanced, the forces aren't the same on every side, each side of the pivot. It's the moments that have to be the same. If the moments in the clockwise direction are bigger than the moments in anti-clockwise direction, then it will begin to spin in that direction. Okay, so they need to be balanced. Both the clockwise and anti-clockwise moments need to be equal. So let's look at some examples of this then. Will the beam shown below be balanced? The first thing I would do is kind of separate out our forces and distances into pairs. So I can work out the left hand side here first. Force times distance is going to be our moment. So the moment is going to be 4 times 3, which is 12. Let's make that 3 times 4 just to make it match up with what's above. Newton meters. But they're trying to make it turn in this direction. That is anti-clockwise. So we might just put an AC in front of our M to keep us right with that. Meanwhile, on the other side, we can do moment equals force times distance. Moment equals 2 times 6. Moment equals 12 Newton meters. That downwards force on the right hand side is trying to turn it that way. That's clockwise, so we can put a C in front of our M there. So will the beam balance? Yes. Doesn't ask us to explain because the anti-clockwise moment equals the clockwise moment. Okay. Will the beam below balance? Well, let's do the same thing. Let's pair up our forces and distances. On the left hand side we have moment equals force times distance, which equals 3 times 5, which equals 15 Newton meters. Once again, that's trying to make it turn downwards on that side, so that is an anti-clockwise moment. Meanwhile, on the right hand side here, our orange circle ones, moment equals force times distance, moment equals 2 times 6, moment equals 12 Newton meters. We can now see that they're not the same. So will this beam balance? No, because the clockwise moment does not equal the anti-clockwise moment. In fact, here, the overall effect of this, if we think back to resultant forces, we can kind of do the same with our moments. And if we have 15 Newton meters clockwise and 12 Newton meters, 15 Newton meters anti-clockwise and 12 Newton meters clockwise, the overall moment there would be 3 Newton meters in an anti-clockwise direction, but you don't have to worry too much about that at GCSE. Next one, find the force marked F if this beam balances. Now there's 2 ways we can lay this out, and we'll do it the way we probably would have done it at in year 10, and then we'll show you maybe a more concise way of doing things. So I pair them up first of all. So on the left hand side we know both the force and the distance. On the right hand side we don't, so we start off with the left hand side. It won't always be the left hand side, but we always start off with the force and the distance that we know. So 20 times 2, which is 40 Newton meters. But that's turning it that way, which is anti-clockwise. And what we know is if the beam balances, and we should write this somewhere in our answer, then the anti-clockwise moment and the clockwise moment must be exactly the same. Dealing with the right hand side then, we can do moment equals force times distance. However, we're dealing with the clockwise moment now, so we put a C in front. And then we write out that equation again, but we put in the things that we know. Now the clockwise moment we weren't given, but we know it's the same as the anti-clockwise moment, which was 40. So because we worked out that, we know that it must be 40 is equal to F times 5, 40 divided by 5 is equal to F, so F is 8 newtons. Okay, that's probably a long-winded way of doing things. What we can do is we can just start off with this statement. So we could just say anti-clockwise moment equals clockwise moment. This force times distance equals this force times distance. 20 times 2 equals F times 5. So you can see it's more concise. That gives us then 40 equals 5F. Divide both sides by 5 gives us F, which is 8 newtons. You can do whichever way you're happier with, but probably at GCSE we'd be expecting more people to do it this way. It is quicker, it's more concise, and it is what we see the majority of people doing in exams. Okay, what I want you to do is try the questions that I've listed below, some from this booklet, some from the textbook, and then we can go over this next lesson.